All right, in the other video from section 7.2 and 7.3, we dealt with the addition, subtraction, double angle, and half angle formulas, but we dealt with them pretty much using them from left to right. Now, this video we're going to deal with using the same formulas, but using them in the opposite direction, from right to left. Okay, so I have this little box again here that gives you the addition and subtraction formulas, and then I tell you to use a sum or difference formula to simplify, to rewrite, then evaluate. Alright, so what I'm going to try to do is try to fit this sine of pi over 6 cosine 3 pi over 2 minus sine of 3 pi over 2 cosine pi over 6 into one of these forms. Alright, so that there, sine of pi over 6 cosine 3 pi over 2 minus sine 3 pi over 2 cosine pi over 6 looks very similar to this, right? Where s is being played by pi over 6 and t is being played by 3 pi over 2. So I have something that looks like the right side of this sign of a difference formula. So what that means is that this is really the same thing as the sine of s minus t, right? And we said earlier that s was being played by pi over 6 and t was being played by 3 pi over 2. And now we can simplify this further by saying, well, pi over 6 minus 3 pi over 2 is really pi over 6 minus 9 pi over 6, which is negative 8 pi over 6. And of course, negative 8 pi over 6 is just negative 4 pi over 3. All right. And going further, we can use our, definition of an odd function, right? Because sine is an odd function, and say that the sine of negative 4 pi over 3 is the same as the negative sine of 4 pi over 3. And now we can evaluate that. All right. Now you might say, well, why didn't you just evaluate it at the beginning? Well, if I evaluated it at the beginning, it was going to be, a more complicated calculation, because I was going to have to plug in values for the sine of pi over 6, the cosine of 3 pi over 2, the sine of 3 pi over 2, and the cosine of pi over 6. So it might have been a little bit more, of a lengthy process. Whereas here I've boiled it down to a single trig function. It's really the negative sine of 4 pi over 3, right? And the sine of 4 pi over 3 is in the third quadrant, right? 4 pi over 3 is in the third quadrant, so sine is going to be negative. So this is actually going to be a positive answer, because it's going to be the opposite of a negative, which is going to be positive, and it's going to be the same as the sine of pi over 3, and the sine of pi over 3 would be square root of 3 over 2. Alright, so the instructions said simplify to rewrite it, so I simplified it down to this and this, right? So I rewrote it as, you can look at it either way, the sine of negative 4 pi over 3 or the negative sine of 4 pi over 3. And then evaluating it means, give a value for it. And there's the value, radical 3 over 2. All right. So there I used my sign of a difference formula from right. Now with the part B, you can see that this one, cosine of 5 pi over 6 cosine of 2 pi over 3 minus sine of 5 pi over 6 sine of 2 pi over 3 looks very similar to this, which is the right side of the cosine of a sum formula, okay, where s is being played by 5 pi over 6 and t is being played by 2 pi over 3. Alright, so what I can do is I can really write this as the cosine of a sum, and that sum would be 5 pi over 6 plus 2 pi over 3. And again, 5 pi over 6 plus 2 pi over 3 is 5 pi over 6 plus 4 pi over 6, which is going to be 9 pi over 6, and 9 pi over 6 is just 3 pi over 2. All right. So again, remember the directions said simplify to rewrite it. So now I've simplified it and rewritten it as the cosine of 3 pi over 2, right, which is basically the left-hand side of our formula for the cosine of a sum. And now I can evaluate it. Well, 3 pi over 2, at 3 pi over 2, the cosine would be 0, right? Because cosine is the x value, and the x value at 3 pi over 2 would be 0. So that's evaluating it, okay? So I've simplified it to rewrite it as the cosine of 3 pi over 2, and then I've evaluated it to be 0. And again, could you have gotten 0 by using the given problem and substituting all your values? Yeah, but then again, you got to do the cosine of 5 pi over 6, the cosine of 2 pi over 3, the sine of 5 pi over 6, the sine of 2 pi over 3. Now, if you're good at that, I mean, sure, you can do it, but it might be a little bit more work. Whereas here we boiled it down to just the cosine of 3 pi over 2. Make it a little bit easier. All right. So that was using our sum and difference formulas from right to left. Now we can also use our double and half angle formulas from right to left. So again, I give you the boxes just to, refresh your memory about the double angle formulas and the half angle formulas. So there they are. And then I say use a double or half angle formula to simplify the expressions and evaluate if possible. All right. So 2 times the sine of 3 theta cosine of 3 theta. Well, the first thing to realize here is I'm not going to be able to evaluate this because I don't know what theta is. Right? So I'm just going to have to leave this in terms of theta at the end. But if you look at this, 2 sine of 3 theta cosine of 3 theta, it looks very similar to the right-hand side of the double angle formula. But again, the difference is that the role of x is being played by 3 theta. So now what I'm going to do is I'm going to write something that looks like the left-hand side of the double angle formula. But the difference is if x is 3 theta, that means that 2x is going to be 6 theta, right? It's basically just multiplying both sides by 2. Right? Not basically, it is. So I'm going to rewrite the left-hand side then as the sine of whatever 2x is being played by. And in this case, 2x is being played by 6 theta. And that's it. Done. It's just the sine of 6 theta. Right? So that was using the double angle formula for sine from left to right. And now this one is pretty much identical, right? The cosine squared of 5 theta minus the sine squared of 5 theta. What does that look like? Well, it looks like the right-hand side of the double angle formula for cosine. But again, the difference here is that the role of x in the formula is being played by 5 theta. So if x is being played by 5 theta, that means that 2x is going to be 10 theta. And again, now I could just rewrite the left-hand side of the double angle formula for cosine, which is the cosine of 2x, which again is now being replaced by 10 theta. So there it is, cosine of 10 theta. And again, like I said, it says evaluate if possible. Here I can't evaluate it because I don't know what theta is. Right? So if they could give me a value of theta, then I could evaluate it. But I don't know what theta is. So I just have to leave it in that simplified form. So that was double angle formulas from right to left. And this is going to be very similar. Because now what do these look like? These then look like the right-hand side of the half angle formulas. Okay, so this one here, 1 minus cosine of pi over 2 over 2, the square root of that, looks like this one. Right? And again, the difference here is that the role of u is being played by pi over 2, which means that u over 2 is going to be pi over 2 over 2, which is really pi over 4. So what is this one? It's really just the sine of u over 2, which is the sine of pi over 4. And now this one, we can evaluate because we know what angle we're dealing with here. We're dealing with pi over 4, and the sine of pi over 4, of course, is radical 2 over 2. So again, here I simplified it, here I evaluated it. So that was just the half angle formula for sine. And then most likely, by process of elimination, you now realize that the last one there, D, is going to be the half angle formula for cosine. Right? So that there, that expression fits this form. And again, the difference is that u is being played by pi over 3. So u over 2 is pi over 3 over 2, sorry, which is pi over 6. So what is this really going to be? This is really just going to be the sine of, the cosine of u over 2, which is pi over 6. And we know the cosine of pi over 6 is just going to be radical 3 over 2. So again, we simplified it, and then we evaluated it. Right? The difference is when you simplify, you can just be left with an expression, whereas when you evaluate something, you're always going to be left with just a constant, right? Some number. So that's pretty much it. Right? That's just using the sum, difference, double angle, and half angle formulas from right to left.